It is 12:47 in the morning on Monday, March 10th. I have done a lot of work recently, and maybe you could probably still hear, but I am still doing homework. I'm less not doing work. I'm just copying down the stuff that I've written on the board from last night, 2 nights ago, for algo. I know I keep talking about algo work, but that is just because I just am doing it constantly. And I've said it's because I'm going to nationals next week. I need to do work. I need to catch up on things and do a lot of it. And my God, this is a lot. And I'm glad that I got ahead on what I could get ahead, especially done with the project, because I swear that if I had to do that project in just one weekend, I still have a bit to do. I have the last problem to do, which is most likely going to be the hardest problem to do. I do have to ask, because I found an optimization for the algorithm that he gave me, but I don't understand if he wants me to create a recursive algorithm or just to modify his cursive algorithm, or just to create an algorithm that is recursive that will decrease the amount of swaps I need to do for the Tower of Hanoi. And I found one, and it's like a good amount of optimization. It's, what is it, like for higher Ks, the higher amount of pegs on the tower, I was getting significantly more. What was it? It was 2 times k minus 3 times n minus 1 to the second power, which essentially means that the higher the k and the higher the n, the more the time this thing saves based in contrast to the original algorithm. And the problem is, I don't know if that algorithm is what he wants, because I didn't come up with my own recursive algorithm. I just optimized his that he gave us, and I really don't want to come up with an own recursive algorithm, because I'll be honest, I don't think I can. Like, I know the things that need to be optimized, but recursion has always just been a little bit more difficult in my head to not wrap around, but to parse through, because a lot of the work that I find that I do well in is when I understand what's happening, because the majority of today was pretty much just figuring out how the algorithm worked with the code that he gave me, or gave the class, not me personally. And like I've done that before in other comp sci classes when I did computer organization, which was doing it was the architecture of a computer. It's like computer engineering, the pure basics of it. And like the end, we created a really small CPU and code, and did a bunch of that stuff. But there was one problem that I didn't understand what was happening, but I could follow the directions. And I was going through, and I got to a point where it's like I had to stop, and I was like, I can do this homework fine, this project fine, from the guidance of the instructions, but I can't do the extensions. I didn't think I would have been able to do the last problem if I didn't actually understand the what was going on and what the things that I was doing was going, because it was about something about turning on lights on a motherboard based on the binary inputs you put in and stuff like that. And it took me a good while to figure out what was happening. But then after I figured out what was happening, it was significantly easier to keep doing the work. And so that was my problem today, is that I was just not knowing how to understand what the program was doing. And so it just took me a long time to actually get going with the work and get going with everything. And I don't know if that happens a lot with any other classes. Like, I feel like this is a pretty STEM-focused problem, like, of understanding how the problem is working it through. But I mean, like, physics and math, I never really had that issue where, like, I could understand going through, but I never, like, had to really stop and think about what was happening and understand it the way that I do with computer science. Like, yeah, I would say that because computer science is more of a problem-solving thing, not in the regard that I think once you get past Algebra 2 and you get into pre-calc, or even past pre-calc, that math becomes less about doing math and more about problem-solving. But it still feels like there's very finite possibilities. There's finite things that you can do, things that you can go wrong, and stuff like that. And in physics, which I would argue is only problem-solving, chemistry is only problem-solving, you only have a set amount of things that can be solved within the context of that class. Like, you're not going to be solving quantum mechanics in an intro to physics or just an electromagnetism class. But there's, like, finite things that you can do within the confines of the equations you're given. In computer science, it's only within the confines of the language itself. And so there's so many possibilities and so many different ways to do things and so many different outputs you can get that I find that computer science is a lot more problem-solving than any other field that I am doing. And I understand that, like, math, once you get to, like, modern algebra and more theory-based stuff, it becomes a lot more problem-solving. And it's probably because, like, I've advanced enough in computer science relative to the other classes that I'm getting to the point where I'm going more theory. Like, I would argue that analysis of algorithm is a theory class. It's actually designated as a theory class within the curriculum and in the major requirements list. And I don't know, it's just, I have to understand things a little bit more and more in depth to fully be able to work them out easier. And it's not like I have to understand it to be able to do stuff with it. Like, I can go through this class and not fully understand a topic and be fine with the homework. But in a project where I'm kind of out on my own, I really, really have to delve deep into the source of what's happening and really get a concept of it before I can go any further. Because once I really understand what's happening, coming up with a new equation is so much easier. Coming up with like optimizations or the run times, it is so much easier to understand once you know what is happening. And the problem with this one is because the Tower of Hanoi is about a lot of different moves and things, and I had to write them out. It was just really annoying on my wrist because I'm writing on the whiteboard, like, for 3 pegs and 3 blocks. That's the algorithm that they were using that we were given is 27 moves. And the only reason that it's different than, like, the 7 or the 15 is because we're only allowed to move to adjacent tiles, while actual Tower of Hanoi stuff, you can move to different, like, you can move 2 spaces over or 1 space over. So, and I had to write that out. And when I was figuring out what to do, trying to find the equation for the amount of time saved for the new one, I had to expand it to, like, 3 tiles and 5 pegs, 3 tiles and 4 pegs, and I had to write all of that out to calculate it myself, and it was just a lot. But it's just, like, it was so easy after that, and realizing that, like, what I did was relatively simple, but it saves a significant amount of time compared, like, when you go up in the amount of pegs. Because for each of the time run analysis, for just the base equation, the amount of pegs is being multiplied through, and there's a big number over onto the right of it as well. And you subtract the number of pegs that you essentially skip with this algorithm, and it's multiplied by the number of pegs you skipped. So it's like it scales well, I would say. And so it's just like, yeah, I'm just saying I'm also to the point in computer science where none of my family members, I think in any regard of any family members are this far into computer science. Like, my mom did a lot of work with computer science, but she's a geologist by trade. And so now I'm beyond her scope when it comes to things I've done in class because she just never looked into this. My dad didn't do any computer science stuff. So when I want to talk about what I find interesting about some of these homeworks and some of these things, it gets really difficult to explain the higher concept things without really writing it down or having a presentation available. It's really hard to express some of these more complex things in words themselves because I'm not skilled enough as a person to say them to somebody that doesn't know anything at all about the topic I'm talking about. That's like when somebody's really, really smart, they're able to say complex things to somebody who doesn't know it and make them understand. And I know the complex things, but I don't know how to explain it in a very good way because I'm so used to other people around me knowing what is happening. And when I try to explain it to somebody that doesn't know what's happening, it's a little bit different. But yeah, that's just what I've been going through in recent times is just like I got to the classroom at 6:00 and I've been doing work for 5 hours now, and like, sure, I maybe took some breaks, but I really was constantly thinking and trying to problem solve for that long. And it gets annoying a little bit because the amount of work that I did one problem in 5 hours. One problem. But now I know exactly what's going on, and I'm probably, the next problem is going to probably going to take me 5 hours as well, but the next problem is going to take a lot less time now that I understand everything. And it's a kind of annoying for the fact that the progress is not the amount of time I've spent does not correlate well to the amount of progress I've gone on, even though I know that those are there. But like in math and other classes, you can do a problem in 30 minutes and it feels like that 30 minutes was a good use of time. In this class at least, I spent 30 minutes on something and I've gone nowhere. And then now I've done 5 hours and I've done a problem that the write-up is going to take about 15 minutes. So it's just the amount of time put in doesn't really match the progress. But like I said, now that I understand really what's happening with this code and with this algorithm that he gave us, I'll be able to go a little bit further and be a little bit faster.